Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of rate of change. This is standard A.3B in the great state of Texas, and we are using item number 2, which is a new item type called drag and drop, off the 2023 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. Alright, so we need to complete a statement here that describes the rate of change of water level. And so if we look back up here, right, we will see that we do have a water level changing at a constant rate. So that's going to be important, the fact that we're changing at a constant rate. That means that we could calculate the slope, since it is that constant rate. And we've got X hours, okay? And then we've got water level on the y-axis right there, okay? So now that we kind of have that, let's take a look at this graph, okay? Because we're going to need to describe it somehow. So the water level, and before we get too far into that, let's take a look at our drag and drop here. This is a 2-point question. So if I wanted to drag this, you notice how it's not letting me drag a number there. So really there's only two options. I can either choose decreases or increases for that first one. And I really can't put decreases or increases over there. So my options are really just one of these three numbers. If I only try to answer with one, it is going to give me an error message saying you have not answered everything. So we need to choose either decreases or increases, because the water level decreases or increases at a rate of, and then one of those numbers. So that's helpful to know. So how are we going to calculate this? Well, if we are looking at our reference materials, since that constant rate of change can be calculated as a slope, since this is a line, look at that very bottom equation on the screen. Slope of a line, m equals y2 minus y1 over x2 minus x1. That's what we are going to do. We are going to just calculate this as slope, change in y, over change in x. Think of rise over run. That's another way we can kind of keep this in mind. Alright, so we need to find 2 points here, and it needs to be integers. I don't want any guesstimating on, decimals and how close they are. So I'm really saying 2. That right there, which looks like to be our y-intercept. If we wanted to put this into a slope-intercept form, right? It looks like that b is going to be 9, because that's where it crosses the y-axis there. So 0, 9 is my point. I'm seeing one other solid point on integers, and it looks like it's going to be that 4, 8. All right, so now that we have those 2 points, that's all we need to calculate slope. So let's label one pair x1 and y1. Let's label another pair x2 and y2. Doesn't really matter which way. If I label the other pair x1 and x2, you'd get the same answer. So let's see, my y2 is going to be 8. My y1 is 9. My x2 is going to be 4. And then that's 0. Okay, so it looks like I've got 8 minus 9 makes 1. 4 minus 0 makes 4. That's really a negative 1. So we could just call it a negative 1/4, which makes sense. I knew this was negative, and hopefully you did too the first second you saw it, simply because it decreases from left to right. If it decreases from left to right, it is a negative slope. It's a positive slope if it increases. So that's our first thing that we can say. We're going to say it decreases at a rate of, well, we have negative 1/4. All we need to do is turn this into a decimal, right? So hopefully we're saying, you know what, that's the same as negative 0.25. The decreases takes care of the negative, so we are just going to pick up that 0.25, and that's your answer.